So I'm Clement Escoffier. Right now I'm a researcher at the Grenoble University, but I'm also driving my own company, Dynamis Technologies, about continuous deployment. And I'm also doing some mobile stuff with OW2, and I'm also working for GitHub at GitHub. Okay, so I will talk about OSGi at OW2. So OSGi now appears more than 10 years ago, and OSGi and OW2 have a really long story. The first question is, this is coming from the OW2 web page. I don't know which page, but you go on the OW2 page, main page, and you will find this. And what is interesting here is this word here, components. Even on the flyer you have just in the big room there, you will see you have components over there. The question is how to deliver components that way we can ensure that they will work together. Because when you start speaking about components, you have architects, software architects, and so on, and managers say, hey, we will do a really great system and it will work like that. So we have plenty of components and we will bind them together and everything will work and perfect. For developers, they say, cool, I don't have to manage all my dependencies or whatever. It will just take these components, and bind them together and gonna work, and it will be perfect, and actually it will make my life much easier. The only small issues is the developers, the operators are finishing like that. So adding modules and components and so on, and you have conflicts and incompatibilities and it doesn't work, and obviously one has an update and so on. So it's really hard to control and to manage a set of components in an homogeneous way. And that's where OSGi is helping. So what's really OSGi? So I will do a small metaphor. You know this is a breadboard. It's used in electronic. It's like, well, it's a board on which you plug components, and you have plenty of components, of electronic components. OSGi is exactly the same thing. It proposes you a board on which you will plug components. They are named bundles, and those components are very particular. First, they have a shape, and OSGi is enforcing strictly the shape of all these components. Components have two different kind of dependencies. The first one is about packages. Components say which packages, so set of classes on which they rely and which ones they provide. So it's like a super powerful jar file, exactly specifying what they required and what they provide. It's not only the name of the package. They also can specify the version range, or use constraint, and so on. It's a really powerful and very descriptive language to describe what you provide and what you can require. However, this is only the first part of OSGi, and it's not the most interesting part. OSGi is mainly used for this, but there is a second dimension, which is named services. Services is the top level of OSGi. With services, your component is not only providing or requiring packages, they are requiring services and providing services. The main difference is services is a feature. It's pretty simple to use. You just use it. You find it, you take it, you use it. You don't have to know how the API is using. It's really, you can consider it as a smallest subset of your public API. So how does it work? It's pretty simple. You have here two components, the red one and the orange one. And the orange one wants to use one service. It doesn't look directly, it doesn't find directly the red components. It first goes to a third tier, which is named service registry. It will do a lookup, and will get some notification when one provider, so these red components, one provider of this service arrive and is available for him. And when he finds it, then it can just be bound to this one and use this feature. The very interesting thing is you don't depend on a specific implementation. You are not depending on a specific logging API or logging library. You just want a log service. So first thing, you don't depend on an implementation. Second thing, it's heavily dynamic. maybe the red component arrives later. There is plenty of reason why these components can arrive later, because maybe it's representing a service which is available on the network, and on the first lookup, the connectivity is down. So there is really lots of cases today where dynamism is really infused in all IT systems, mobile, server, anywhere. I will mention it a bit later. So here is about this dynamism. Imagine this red components, which is requiring a remote service, like remote database or whatever. The cool thing is we have these purple components over there, which is using a service from the orange component and relying on the red component. Unfortunately, for some strange reason, the connectivity is disrupted. You are in a tunnel or whatever. So this service, the component provided by the red components, the service provided by the red components is not available anymore. The orange component is immediately notified and can decide to change to another component which does not have this dependency on network. Maybe local implementation, maybe a kind of buffer or whatever. You are not depending on one, you can just switch to another one dynamically. OSGi is managing all state integrity and so on, so you don't have to bother about all these details. So let's come back to the point, OSGi at OW2. So the story started around 2005, and we have plenty of projects relying or extending OSGi. Let's first set OW2 utils, which is a set of libraries which are packaged as OSGi bundles ready to be used. You have plenty of utilities like log, like class loading, and so on. So just pick some. They are really robust, used in production. Most of them come from the Jonas project. We'll talk about Jonas a little bit later. So just use them if you have such kind of needs. The second one, which is one of the major OW2 projects, very visible, is ISM. ISM is fully packaged as an OSGi bundle, and it's a really good one, really expliciting the dependencies, the required dependencies, and so on. Then we have Joram, and we have plenty of others. All those libraries are on the first level. They are providing packages, but not services. Another project that I know pretty well, as I'm the leader of this one, is Chameleon. Chameleon, in phase, really focused on the service level. I don't want to hear about, yeah, I need this package and so on. What I want to hear is, I need this service, whatever implementation is available right now. And if the one I am using is not there, then I will switch to another one. So we have defined we have 30 or 40 different service interface about syndication, about databases, about mails, and so on, not depending on the implementations. Implementations are really something that we hide, and we can just say about mail, well, it can be IMAP, it can be a Gmail, it can be whatever, Outlook. I just need one. I will configure my system to use this one, and if I want enough time it doesn't work, then I will switch back to another one, like a failover. Another project is Shelbie. Shelbie is was initially developed by the Jonas teams, and it's have its own life since now a couple of years. It was the Innovation Award of the last year. It's led by Guillaume Sautier, and it's a shell. It's a really advanced shell, so where you can connect. So let's imagine you have an OSGi application somewhere in the cloud. You can connect to this application using SSH, operate it. So listing bundles or doing some actions or retrieving data and so on. You can really do whatever you do with your own shell, but it's inside your application. It's really powerful. You have auto-completion, you have colors and so on. It's, for me, and I'm using OSGi since more than 10 years now, it's the most advanced shell we have. It's even more powerful than the Karaf one. Then we have other projects like Jonas. Jonas was a really big contributor to the OSGi community because it was one of the first Java EE, Java Enterprise server switching to OSGi. It was the first one. Now, except Red Hat, GBoss one, which made a strange turnaround on the top of OSGi. Also, the one that's based on OSGi. Why? Because when you have more than 100 jars to manage, all those dependencies, if you don't have a really, really strict model where explaining which jar is providing which packages and on what they rely, you have no way you will control that. You imagine like Glassfish or, I don't know, WebSphere, with all those jar files they took all over the place. If they don't know, hey, if I update this, what is broken? Because updating a jar, you can be sure that somewhere in your application something is going to be broken. We have also Frascati, which is an SCA implementation on top of OSGi. We have really, really lots of projects. Okay, but what does OSGi really improve? That's a key question today. So now, since 10 years with OSGi, we have some ideas about what is improved. The first thing is that it will make your application much more modular. You will divide your application in a set of bricks, a set of modules, and you will know exactly which modules communicate with which one and how, and you can so control and test every component independently. You can even develop component independently. And that's the second thing. If you can test and develop independently with a different evolution pace, then your quality is much higher. All components, and we will discuss that with, we'll see that with Nicola in another talk tonight. All components are tested, really carefully. They can mock everything they require as it's relying on services, so you can really mock it easily. So you are pretty sure about how it reacts, how it behaves. Integration is much, much easier. You don't have to say, oh, okay, something is broken, everything. Somewhere. You know exactly where it is. The second thing is control. You know, you can go using Shelbie, for example, you can connect to your app and say, hey, oh, this one is deprecated, or this bundle is deprecated, or there is a new version. You can exactly, you know exactly what need to be changed, or it's really modular, so you can really control finally what you are doing. The last things, and that's more difficult to understand, even if you have an overhead when you start your project, because you have rules to enforce. On the long term, your development is much, much faster, because you can reuse more easily everything you have developed and rely on all the components that the community, like OW2, Apache, Eclipse, and so on, are providing. So that's my last slides. I don't know if you know Play Framework or Grails or such kind of things. So since a couple of years, I was thinking to develop my own, but in a really, really dynamic and modular way, which are the same features as Play Framework. So you just save and it refresh and so on. But I want to deploy my application in really small pieces, my web applications. I did it. I did it in less than 1 week. And I'm feature complete in comparison to Play Framework. Oh, because I'm just using OSGi and I know all the components and I can control everything. Thank you. If you have any question.